All right, well, good morning again, sixth graders. And we are looking at our last lesson in Chapter 8 today, Lesson 8.8b, continuing to talk about inequalities. Now, this first set of instructions, because you got three sets of instructions that we're going to go over. The first set of instructions says to write the word sentence as an inequality, then solve the inequality. So we're looking at these word sentences here. We look at this first one, and it says 7 more than a number is less than 28. So first of all, we've got to analyze what that means. It says 7 more than a number A, is less than 28. Well, 7 more than a number A is going to be A, and since it says 7 more than, it's going to be A plus 7. So it's 7 more than a number A. We're starting with A and we're adding 7. And then it says is less than 28. So we're going to use the inequality sign less than 28. All right. Then we need to solve the inequality. Now this is exactly what we did yesterday. Okay. It says A plus 7 is less than 28. So we're going to think of A plus 7 equals 28. All right. And then we're going to subtract 7 from both sides. My mistake, wrong number there. I'm thinking ahead. That's 0. 28 minus 7 is 21. So that leaves us with A equals 21. Well, then I need to go ahead and graph that, and it's the idea that A has to be less than 21. So it's going to be an unshaded circle that starts at 21. It's going to go to the left, and it's going to be 20, 19, 18, 17, and so forth. All right, so this is when we talk about solving the inequality, that's what it means. You're writing it as the inequality, then you're solving it by graphing it. 9 times a number y is less than 72. 9 times a number y is less than 72. Well, 9 times a number y, the best way to show a multiplication problem with a variable is a number right next to the variable. So 9 times y, and then it says is less than 72. So once again, we're using the less than sign, and it's less than 72. So that's the inequality. All right. So here we go again. We want to think about 9y equaling 72. And to isolate y, we're going to divide everything by 9. That's going to equal y. We're going to do 72 divided by 9, which is going to equal 8. So we get y equals 8. But so we know now that y is less than 8. Okay? That's what we want to think about, y being less than 8. So what we want to do then is we want to go ahead and graph it. It's going to be an unshaded circle because y cannot equal 8. It has to be less than 8. Okay, and we're going to move it left, and it's going to be 7, 6, 5, 4, and as always, at least 5 numbers. All right, 225 is no less than 3/7 times a number x. 225 is no less than 3/7 times a number x. Well, 225 is where we start, and it says it's no less than. Well, no less means that it can equal that, but it can also be more than that. It's just not less. So the idea is that 225 then is going to be greater than or equal to whatever 3/7 times the number x is, and I'm going to show that by putting 3/7 x. Well, now I need to solve that, all right? So 225 equals 3/7 x, all right? Which basically then tells me that x is going to equal whatever 225 divided by 3/7 is. So I have to isolate the variable by taking 225 over 1, and since I'm going to be dividing it by 3/7, I'm just going to go straight to multiplying it by 7/3. All right, well, I can cross-check because if I see 2 plus 2 is 4 plus 5 is 9, 225 is divisible by 3. So I'm just going to come over here real quick, see if I can't figure out what 225 divided by 3 is. Well, 3 can go into 22 7 times. 7 times 3 is 21. 22 minus 21 is 1. Drop the 5. 3 can go into 15 5 times. None left over because 3 times 5 is 15. So that's going to be 75, as I got there. That's going to be 1. So I get 1 at the bottom. And then it looks like I just need to do 200 or 75 times 7. So I'm going to come over here, 75 times 7. 7 times 5 is 35. Put the 5 down, carry the 3. 7 times 7 is 49. Plus 3 is 52. I get 525 over 1. That equals 525. So now that tells me that now x is on this side. So don't be confused, once again, when the x is on the right. The variable x is on the smaller side of the inequality, which means my graph has to go to the left because it's on the smaller side. Now it's less than or equal to, so it's going to be a shaded circle that starts at 525. And since it's on the smaller side of the inequality, it's going to move left 524, 523, 522, 521. All right, that's writing the word sentence as an inequality, then solving the inequality. All right, well, let's move right along because like we said, we had 3 parts today. The second part says solve the inequality, graph the solution. All right, so solving the inequality, graph the solution. All right, well, first of all, we got x plus 7 minus 4 is less than or equal to 18. Now, we know that we're going to think about this as x plus 7 minus 4 equals 18. Then I'm going to combine like terms. I know that 7 minus 4 is 3, so x plus 3 is going to equal 18. Then I'm going to subtract 3 from both sides. That's just going to give me x here, and 18 minus 3 is 15. So I get x equals 15. Well, x is less than or equal to 15. So it's going to be a shaded circle that starts at 15. And since x is less than or equal to, it's on the smaller side of the inequality, my line's going to be moving left, 14, 13, 12, 11. All right? 56 is greater than or equal to 3h plus 5h. Well, once again, we're going to think about this as 56 is equal to 3h plus 5h, which means that 56 is equal to 8h, which means if I divide both sides by 8, I get that 7 equals h. All right? So now I know that that 7 is greater than or equal to h, because I got 7 over here greater than or equal to h, which means h is on the smaller side of the equation, which means it's going to go left, which means I'm going to have a shaded circle because it's greater than or equal to. It's going to start at 7, and it's going to move to the left, 6, 5, 4, 3, and so forth. All right? One more, then we'll move on. 3x divided by 2.8 times 18. 3x divided by, 3x is greater than 2 8/10 times 18. Well, first of all, we're going to think about this as 3x being equal to 2 8/10 times 18. So the first thing I have to do is just figure out what 2 8/10 times 18 is. So I know 3x equals that. So I'm going to come over here. 2 8/10 times 18. 8 times 8 is 64. Put the 4 down, carry the 6. 8 times 2 is 16. Plus 6 is 22. Put a 0 down to line it up with my 1. 1 times 8 is 8. 1 times 2 is 2. Going to add these together. 4 plus 0 is 4. 2 plus 8 is 10. Put the 0 down, carry the 1. 2 plus 2 is 4. Plus 1 is 5. One digit that comes after the decimal in the problem. So I need one digit after the decimal in my product, 50 and 4/10. So I now see that 3x equals 50 and 4/10. Well, it says isolate x. I've got to divide both sides by 3. That gives me x here. So I'm going to have to come down here where I've got some room and take 3 into 50 and 4/10. I'm going to bring my decimal straight up because there's no decimal here. 3 can go into 5 once. 1 times 3 is 3. 5 minus 3 is 2. Drop the 0. 3 can go into 20 6 times. 6 times 3 is 18. 20 minus 18 is 2. Drop the 4. 3 can go into 24. 8 times. 8 times 3 is 24, so I know there's none left over. X equals 16 and 8/10, or 16.8. Well, now I need to graph it. Now it says that 3x is greater than the product of 2 8/10 times 18. So I know that x is greater than 16.8. Not equal to, greater than. So it's going to be an unshaded circle that starts at 16.8, and it's going to move to the right. Now you can do a variety of things here. You can do 16.9, 17.0, 17.1, 17.2. That would be fine. You could also do what I'm going to do here. Go 17.8, 18.8, 19.8, 20.8, and do it that way. Not really a right or wrong reason to do that. You could even do 16.81, 16.82, 16.83. Something like that would work as well. All right, last part. What numbers are solutions of both inequalities? What numbers are solutions of both inequalities? And we're going to do one example here. You're going to get a section that's going to give you two inequalities. You're going to have to solve them both. You're going to have to figure out what numbers they are. Now, you don't necessarily need to graph it. You just need to figure out what numbers actually fit. Okay, so let's look at an example. X plus 7 is greater than 9. So you want to think x plus 7 equals 9. Okay. Now if I subtract 7 from both sides, that's going to leave me with x over here. 9 minus 7 is 2. So it tells me that x equals 2, which means my actual inequality is x is greater than 2. So this is actually what I'm going to be thinking about when I come back to it at the end. Here we have 8x is less than or equal to 72. Once again, I'm going to think 8x equals 72. If I divide both sides by 8 to isolate x, I do 72 divided by 8. That gives me 9. X is equal to 9, which means that x is less than or equal to 9 is the actual inequality that I use, because that's the symbol that it gives me there. So now I'm looking at these two inequalities. X is greater than 2. X is less than or equal to 9. Well, if x is greater than 2, that means any number here that's greater than 2 is allowed to be here. If I'm looking here, x is less than or equal to 9, it means anything 9 or less can be here. So over here, I need something that's 3 and bigger. Over here, I need something that's 9 and less, which means that the numbers that are solutions of both inequalities are 3, 4, 5, 6, 7, 8, and 9. And I would need to list all of those numbers. Sometimes you might get just one number that's a solution of both. Here's an example where we had several. But you got to figure out what the inequality is for both of the solutions, and then figure out what numbers would work that would make it true for both inequalities. All right, we'll talk to you later, 6th graders. Bye.